Hello, in this video I will talk about passing variables to functions in three different ways. We can pass variables by values, or by reference, or by pointers. And I will separate this lesson in two sections. In first I will talk about the plain old data type, which means like integers, booleans, doubles, characters and things like that, like variables which have the type from C language. Like here we have an integer. And in the second section I will talk about passing like objects, because we will get more issues when we pass objects. Let's start with the simple ones, which are the plain old data type. Like in this example I will use an integer. Let's say that we want to calculate a sum of two numbers. So here we have two variables, x and y, and we want to call this function sum. And okay, so this first one will be passing by value. This is what this one is. The first one is passing by value. So what happens here is that when we call this sum with x and y, what happens when we go here is that this sum function will create a local a, and it will initialize a with whatever is here. But it will be a copy. So maybe I put it like this. It's easier to see what's happening. So it will create a local variable a for this sum function, and it will copy x value into it. And the same way it will create a new local variable b, and it will copy this value into it, like this. Okay, so this will be a copy of x. So this a here is a copy, so it's an independent of, it has the same value what x have, but they are independent variables. So if I change a, it doesn't affect x. Okay, so this one, we run this program now, we will get result like this. So we get the 13 over there. So let's see next what happens if we pass by reference. I have already made this code. Before, so I will just copy this code now and replace this one. Okay. We have more options now if we are passing by reference, so that's why this is a little bit longer, this code. Let's start and first do the same thing, this sum with the reference. Okay, so now we have again x and y like before, but then we need to one way we can use a reference is that we can receive the result as an output from the function. So this last parameter will be a reference parameter here. So we calculate the sum, and then we will return the result in the third parameter. So now we need to do this, we need three variables here, and the calc result variable will receive the result. So let's see what happens in this call. When we call this here on the line 25, let's see what happens. Like before, we have again, we will create a new variable a and copy the value x into it. But the third one will be like this. We will create the reference variable result, local reference variable result, and it refers to calc result in this case. So this is what here happens here. So now result and calc result, they are the same. They are pointing to the same variable in a way. So if we change result, it will also change this one. Okay, so here we are setting result to be a plus b. Because it's a reference variable, this one now after this call, this calc result variable contains that value. So that's why we can print it here. So this will be 13 now. And the second thing we can do here is that okay, the reason why I made a second function here is that I'm just showing that using reference variable, now we can return two values. We can return one value as a return from the function, like here we are returning the Boolean value, which means that was the divide operation successful or not. And this result variable here will receive the result. So let's see how we call this thing. We are calling it here. So we're calling the divide function, and we are passing again this x 10 here, and we are passing the 3 here, and then we want to receive the result into this calc result variable. So here we are checking that because we are dividing this one by this one. So we need to check that the denominator is not 0. That's what we are doing here. We are checking that if the denominator is 0, we will return false, which means that we were not able to divide. There was an error. We can't divide by 0. That means that we return false. And if everything was fine, we will return true. So now we can get two return values. One is the function return, and the second one is the parameter output return here. Okay, so if the if the return value of the divide is true, we're gonna go here and we will print this result. Else we will just print that error, we cannot divide by 0. And we can run this program now. So here we can see that everything is fine, and then divided by 3 is 3. Now if I put here 0, let's see, it also works. And there we go. It found out that it can't divide by 0. So this is the benefit with passing by, oh sorry, there's a reference. But passing by reference, we have this extra benefit that you can pass more values and receive more values from the function. Obviously we could do more here. We could even add more here. Let's say that we have double something, result 2 or something like that. So we could get more results from the function if we wanted. Okay. So let's now go and see what kind of call we will have if we have a pointer. We are passing by pointer. And now it becomes like this. So this is passing by pointers. Passing variables by pointers to a function. So let's see the sum first. Obviously, if we are passing the integers to a function, the only reason we would really use a pointer here is that we would receive the result via this pointer, a bit like same way like we did with the reference variable, that we received the result via the reference variable. The same thing here. We are just using a pointer now instead of a reference variable. So this result will be the result. And again, we need this calc result variable to receive the result. We call this sum function with x and y, and now we need to, the only difference really here is that we need to pass the address of the variable here, so that this one can receive the address. This is a pointer variable, so pointer variable needs an address. So it will be, so what happens here is that result becomes the address of calc result, like this. So now after this, if we are using result after this here, this is how we use the variable itself. We need to dereference like this. So this is now the same variable as this one here, this calc result, because we are pointing to this variable now. Right. So that's why we can set, when we are setting result to a plus b, it will actually set this calc result now to a plus b. And when we are printing it here, it's 13 again. Okay. Okay, and then we have this divide function here, and the same way we just need to put an asterisk here, so we can use pointers, and we are passing again the address of this variable here, and we can do the calculation like this again. And we need to check the denominator like before, so there's nothing else changing here. One thing I want to say here is that this is a little bit more dangerous, this pointer passing by pointers, because what if we change this where it's pointing to? Let's say that by mistake I do this, okay, for example like this. Well, I would never do that really purposely, but let's say that I'm very tired and for some reason I leave this here. So that means that I just changed the point to nil, to 0, and now this will crash probably. So that's the danger here. With the reference variable we did not have this problem, because you can't set a reference variable to refer to something else. It can only be initialized once. But pointer can point to many different places, and you can change where it points to on the next line. So I would say that this is a bit more dangerous, can be more dangerous. Although, just thinking, how about this one? Not this one. Okay, pointers are known to be more dangerous than reference variables, so the recommendation is to use a reference variable here. Okay, let's next go and see what happens when we are using objects instead of plain old data type. And let's start with passing by value. So my example is now like this. So we have this person details here. We have name, age and ID. Each people have name, age and some kind of ID which identifies the person. And the way we will use it, let's say that we have a driver, teacher and police. So now we fill up the driver's details first, and then we will fill up the teacher's details. Okay, the name of the teacher is Peter, the age of the teacher is 54, and this is the ID of the teacher. Now, how would we have a function which will ask the details and fill up the police? For example, the police. Well, we can create a function like this, and we can create a temporary person details object here, and then we can ask from the user all the details. So this will this will ask the name, this will ask the age, and this will ask the ID. And then we will return this object whoever is calling it. So, and here we are making copies. So the values of this temporary object will be copied into the police. So now police contains all these values because this is a copy operation here. So we are copying the data from this one to here. Now some might think that okay, but this is a heavy operation. We are creating a temporary object here, and then we need to delete this temporary object and copy. But actually in the new C++, this will be a move operation. This will be a move operation, which means that it is a very fast and efficient call. So this is all fine. This is all fine. This is okay, this call. So there's nothing wrong here really. This is all good. And obviously we could also set the other object. We could set teacher as well, isn't it? We could ask from the user the values for the teacher, but we already filled it up here, so let's not do that here. And then we will print all the person details here. That's why I created a function called print. Let's go what the print is doing. So here's the print function. So I'm passing, and now another thing is that I'm passing it by value here. This is the value, this is the object. I'm passing by driver object value. I'm passing this driver object by value here, and it will be copied. So what happens here is that this print function again, this is what happens. This function will create a local variable person, which is type of person details struct, this one, and then it will copy this object into it like this. This is what happens. So we will create a new object here, and we will copy driver's value into it, and then we gonna run this code here. First of all, I created a constant field with 7 so that we can I will run this program so we can see what's happening, and then I can explain. Okay, so now it's asking the name. Let's say like Williams 23, and ID is 5544. So now it's printing all the people like this, and last one it prints what I entered here. So now let's go and see this thing. So this is the field. If I run it again, just put so we can see that Williams. Okay, so now we are looking at this. So so first I set the field length here to 7, so that's the 7 here, and I print on the left that field. I will print name here, and after so the field ends here. So now I'm printing John after person name, which is John in this case, and the same thing with the age. I'm printing all of them here, and then I'm doing the same thing with the teacher and with the police. Now this was passing by value. The problem, not a problem, but there is one issue here, which is why we don't normally prefer doing like this, because we need to create this temporary object here, person. In this case, we need to create a string, age, and ID here. Always when we create this temporary object, this one here, we need to create all these variables, and we need to copy one by one, for example, the driver values into this. So that's a bit heavy operation. It can be it's not very heavy in this case because we have only 3 of them, and they are small variables. But what if this was like a matrix or some kind of bitmap which has like million values or something like that, like an array with million values. So we will be copying million things. So it would be very inefficient way. Why would we make a copy of person? Because we are just printing its details. And that's why the next method is better than this, which is doing the same thing. We are doing the same thing by reference. And I will copy this code. And paste it here. Okay. The second version is that we are passing by reference, and it's here. Okay. So what is the difference? What is the difference here? The difference is that now we are copying it by reference, and we are not making a copy. So in this reference version, which is here, a person is referring to the driver. So we are not making a copy, but the person is the same as the driver now. It's not a copy, we are just pointing to the same object. And the const here makes sure that we can't change this value, because we are only getting the values. We are not changing any of these name, age or ID. So we are promising by const not to change this calling variable, in this case the driver. We are only using its values. So this will be a much faster way. We are not making any copy, we are not making any heavy operations. So this is the best way to pass the value. And let's see, add details. Okay, ask details. Okay, so the ask details now changes a little bit, because in the first version we had to use the return value, but in this case we can use the function parameter as an output parameter. So here we are asking the details for the police. So I'm passing this police object here. So the person becomes here police, like this. Now, because it's a reference variable, it means that if I change person's age, for example, this will change the calling variable, which is the police's age as well. So if we are set this one to 88, that means that police also has now age 88, because they are referring to the same variable. Okay, so that's why when we're asking values here, name, age and ID, they cannot actually change the police's values. So this is passing by reference, that we can actually change the object via the function parameter. Everything else is pretty much the same here. Okay, and lastly, let's go and see how we do this thing if we are passing by pointer. Okay, so here we are passing by pointer, and let's see what is the difference here. Okay, first we are printing the person. This const makes sure that when we call this print and we are passing its address, for example, we want to print driver's details, we need to pass the address of the driver if we are doing by with pointers. So we're passing the address of the driver, that using the address, this print function is gonna get access to the driver object, because it knows where it's located at. It knows its address. So this is a pointer variable which can now point to that object. It contains the address of that object, and this const makes sure that we can't change the content of the person, because we are only printing the values. We don't need to change anything. So if we try it, if I try to change this one age, for example 77, we can see that the compiler is complaining that must be a modifiable L value. So this cons makes sure that I can't modify this object, for example this driver, by accident here. It's a safety issue. Okay, the first good thing we need to do here, we need to check that is this a nil, this pointer, just in case, because if it's a nil it will crash this program. So we check that if it's a nil, just return. So we can see that the difference against the reference variable is that with the reference variable we didn't need to check the pointer because it was always valid value. But with the pointers we have to kind of do some checks here, I would say. At least the nil check. It can be nil. It is common that people are using nil pointers, so somebody might pass a nil here. So just in case, it's good to check it against a nil. If it's a nil, we will return and do nothing. And then we can print the values using this arrow. So if it's a pointer, we can use the arrow to get access to its members. So person's name, person's age, person's ID. Okay, and let's look at this ask detail next. Okay, so again we need to pass the pointer to the object which we want to change. In this case we want to ask from the user the police's details. So we are passing the pointer, police pointer there. Again we are checking that if it's a nil we will return, because maybe somebody passes a nil here, so we can't obviously use a nil pointer. If it's not a nil, we will just use this pointer like we did here. We are copying all the values from the user to the corresponding variables, and that's it. So now, what is the danger here? Well, again we have this problem that the user can by accident change this pointer, for example to nil pointer, or he can set this to point to some other person details. If we do this one here now, it will crash the program. So there is always this danger that the user is changing this pointer to point to somewhere else, and we don't have this problem with a reference variable. That's why I would recommend reference variable here. Okay, so I hope this helps. I had a couple of examples here, and thank you for listening. Bye.